Howdy. Today's topic is, of course, foamed asphalt. Jeff mentioned it earlier. We had a energy section workshop, and we hosted it there at the Corpus District. We had several districts in attendance: Yoakum, Laredo, San Antonio, ourselves, and Brian. And we had a very good exchange of information. One of the things that came from it is, of course, this foamed asphalt. That's something that San Antonio was going to do. We got very interested in the process, and we quickly informed ourselves on how to go about it. And we had an ongoing job on FM 99 that we felt was an excellent candidate. And just want to give a word of thanks to the maintenance division. Mark McDaniel and Brian, and of course Howard and Carolyn. They were extremely helpful in facilitating the process. So today's discussion, we're going to talk about traditional stabilization techniques. What exactly is foamed asphalt? Pavement design testing needs, because not every roadway is a candidate. You have to do several steps just to ensure that your roadway is a good candidate project. Then I'll actually get into the case study, and then finally, what you're all here for is cost comparison. Okay, traditionally, we've used several stabilization techniques, primarily in our district, cement, and cement's performed very well. It has some inherent problems or difficulties, but before we were dealing with the heavy oil field traffic, they weren't as hard to handle. But now that we're experiencing heavy oil field traffic in some of our counties, they're getting harder and harder to deal with. Because it is a cementitious stabilizing agent, they're very rigid by nature, which tends to manifest itself because they are continuously bounded into, they're prone to shrinkage cracks, and that manifests itself as block cracking. And under heavy ESO loading, they tend to fatigue out. Another problem that we've seen with them is the inability to get a good finish. We've got some contractors that do 4 transports a day. They'll do 2 transports in one direction till about noon, and then switch traffic and do 2 transports on the way back. They're very efficient at it, but because we don't allow for proper curing, our roadway surface suffers for it. Another stabilization technique that's been used, we haven't used it as much in Corpus, but is asphalt stabilization. Maintains a very good amount of flexibility, but it is prone to rutting. It does use a small amount of cement for some strength, but again, we haven't used it as much in our district. So what is foamed asphalt? This gentleman here, his name's Edward Bernal. He's our Live Oak County maintenance supervisor. And when we were doing 99, back in 2011, I was the Alice area engineer. 99 was a problem back then, and he'd been anxiously awaiting this project since then. So when he found out that we were going to experiment on one of his roads, he was apprehensive, to say the least. He had a couple of choice words for me, and basically saying that I told him we're only going to do a mile. He said, "Well, that's a mile I got to deal with when y'all are gone." So they're the guys I listen to. They're the guys that are out there every day. They're the guys that have to deal with it if we make a mistake. So he is my litmus test, and they all are. Okay, so foamed asphalt, aims to combine the best of both methods by using a minimal amount of cement to act as an active filler therefore retaining strength without affecting the flexibility of an asphalt stabilized base. As you can see here, what you want to do is land in between just slightly lower than your cement treated base and slightly less than your asphalt concrete. Before we start foaming, make sure that your roadway materials are good candidates for the foaming process. The two primary criteria that you need to look at is your gradation curve and your plasticity index. This is a graph showing an ideal gradation curve anywhere in between these two red lines. You need to have a fair amount of fines for it to be a good foam candidate. Another representation of the same graph, if you look at it here for a foamed asphalt candidate, you want a minimum of 4% fines. A lot of the materials that are, or a lot of the roadway materials that are submitted, of course, don't have an ideal gradation. So, in order to get them in spec, you need to add some fines to it to get them in line. And that's how you determine if you have a good foaming candidate. The next thing you got to look at is your PI of your materials. Some of our existing materials are old caliche bases, and of course some of those caliche bases have a allowable PI of up to 16, so you need to make sure that your existing materials are good candidates. Generally you want to stay with a PI less than 10. What happens is with the existence of clay or the presence of clay, they tend to lump together, and these tend to remain in the new base section as localized weak spots. So once you've determined you have a good foaming candidate, you can go ahead and try it and prepare a pavement design. With that, we use a special specification 3279. I want you to pay close attention to the foamed asphalt properties. These are extremely important when you're out in the field, and determine what kind of asphalt you use and what kind of cement you use in the process. Okay, so the two things you looked at, I pointed out to you there, were the expansion ratio and the half-life of the asphalt. The expansion ratio of the foam is a measure of the viscosity of the foam, determines how well the asphalt will disperse in the mix. The half-life is a measure of the stability of the foam and provides the indication of the rate of collapse of the foam. The one thing that affects both of these properties is the amount of water you put into it. So by increasing the rate of water, it increases the expansion rate of the foam. However, it decreases the half-life of the foam. Therefore, the percent of water to add is critical. In order to determine the percent water that you add, you take that 8 times expansion rate and 6-second half-life, and you get an equal space in between, and that determines your optimum water to add. Your active filler, in our case it was cement. You could use lime, fly ash, and a number of other products. We had cement on the job, so it wasn't an issue. Active fillers improve the adhesion of the asphalt to the aggregate, improve the dispersion of the asphalt in the mix, modify the plasticity index of the materials, and increase the stiffness of the mix and the rate of strength gain, and accelerate the curing of the compacted mix. So once you know your active filler, once you know your water rate and your bitumen and everything else, you can go on and move on to actual pavement design. This is a shot of the foamed asphalt lab pug mill mixer that they have at TTI. Pretty expensive piece of equipment. As far as I know, it's the only one in the state. So you can invest in a high dollar piece of equipment, or you can do what we did and contact this guy. And, he, again, working through the maintenance division, we were able to tap into Tom Scullion, and he prepared our pavement design. He came up with a mixed design of 11 inches with a 2.4% foamed asphalt and a 1.5% cement. Okay, so now to our case study. This is FM 99. It's in Live Oak County. It runs from alternate 281 to the McMullen County line. It's about a 5-mile section. Like I said, we were already under construction, and we did this foamed asphalt project as a change order in this little 3/5 of a mile section. So our test section went from the railroad tracks to the Atascosa River. Just a screenshot of the amount of active wells on FM 99. As you can see, these are the only way to access any of these is through 99. A lot of horizontal drilling going on, a lot of pad sites, a lot of heavy trucks. A shot of some of the traffic that we were seeing, and again, these heavy trucks don't do your roadway finish any good. The combination of heavy drilling and heavy oil field trucks, their marriage is good for the economy, but it provides ugly stepchildren, and this is part of the result. So our typical section consisted of cutting down at the pavement edge. Our existing section was about 20 feet wide. We cut down, added 8 inches of type A grade 1 material on the edges, and cement treated that with 2% cement, and then we came across the top with 6 inches of type A grade 1. And that was our section in the other parts of the project. Of course, our new section consisted of the foamed asphalt, and we did that for an 11-inch depth. The station limits that we modified were from roughly station 840 to 4150 for a width of 30 feet. Okay, so foamed asphalt mechanics. The way it works is your transport truck comes in with your PG binder, in our case 6422. It comes in at above 300. Temperature varies. In this case, it was 325. We test the foam bubbles, just like I mentioned. Test your expansion rate, test your half-life, and then these particles are compacted, pressed, and adhere to larger aggregates, resulting in localized non-continuous bonds. So we begin by spreading out our cement. Like I said, we were at 1.5% cement. We spread that out on the existing base. We then got our asphalt truck in place, and we tested the foaming characteristics as per the spec. We used this incredibly technical piece of equipment here to test our expansion rate and our 6-second decay. Lucky for us, the equipment we were using was a VertGen mixer, and it had a special nozzle that allowed you to do it pretty easily. Once you check your foaming rate, then you can go ahead and start your foaming process. And the way it works, you have a train, essentially. Your asphalt truck can be either in the back or in the front, and it is pushed along by your mixer. Your water truck can either be in line or behind, and they're both injecting the asphalt and the water into the mixing drum. I've got a little video that shows the process. It's here somewhere. There we go.
There should be a play button come up in the lower left.
In real life, it moves a lot faster than that. As you can see, the asphalt truck is being pushed by the mixer, and it is towing the water truck. You got the hoses connected directly into the mixing drum, and in this mixing drum is where the magic happens. I've got another little clip of an animation showing exactly what's happening in this mixing drum.
The powerful milling and mixing rotor granulates the damaged pavement layers. The pre-spread cement is mixed in at the same time. A special injection bar with expansion chambers produces the foamed bitumen and sprays it in. Water added to the process causes the bitumen to foam abruptly, expanding it to many times its original volume and distributing it evenly in the mineral aggregate mix. At the same time, the amount of water required for the mixing process is added via a second injection bar.
So there's the foaming process.
Scully's brother.
Yeah, they speak that extinct language, proper English. Okay, immediately behind the water truck, since we were treating an 11-inch layer, is the roller, and in this case we used a 20-ton roller, a 20-ton pad foot roller followed by a 20-ton steel drum roller. We were able to get compaction in 5 passes. And this was verified by Tom Scullion and his group, doing some dynamic cone penetrometer tests at every inch. Again, once the rollers are done, you can immediately shape the layer. One thing that stood out in my eyes is when we started shaping the layer, the blade actually cut the larger aggregate in half because it was so bound. The fines had welded the larger aggregate in place, and it was shearing the larger aggregate in half. Once it was finished, we applied a little fog seal just to maintain the finish. And then that weekend, of course, Murphy's Law struck. We got 4 inches of rain. And of course, we were worried about how it held up, but it held up remarkably well. Here's a picture of. We had some issues with some transport trucks, so we weren't able to do the entire 30-foot width. We cut it short at the last day because of our issues with the transport trucks, and this image here shows basically the limits of what we did on the foamed asphalt versus traditional cement stabilized base. So it's kind of a night and day comparison. So we didn't have a good handle as far as our moduli and what the foamed asphalt was going to give us. And what Tom and Joe Leidy and Mark have found is that our moduli came in very high. A 493 versus a 545. Now, of course, this is only one data point, so you really can't hang your hat on it. But depending on your materials, you could be looking at moduli in the 400 range. Getting the hook. Okay, this is the picture of our finished product. Now, what about the cost? Because it was a change order and because it was done, our contractor wasn't prepared for it. I think we paid quite a bit higher cost per square yard than we traditionally do. It came in at $21 a square yard versus our traditional $350. There are some things you can look at as far as reducing the cost. We use a PG binder 6422. You could possibly look at using an asphalt or even an emulsion. We had issues getting asphalt. We were doing it in the heat of seal coat season, so getting asphalt was an issue. So they gave us a pretty good price. Another thing that comes to mind is the fact that we didn't know what we were dealing with as far as moduli. So when we did our pavement design, it's probably a little bit conservative. With such high numbers, you can probably reduce your thickness maybe not look at 11, maybe look at something thinner, so that would affect your cost. Because, again, the contractor didn't have some of these bigger pieces of equipment, a lot of those costs are incorporated into the square yard costs. So we didn't have any 20-ton rollers on the job because he wasn't compacting 11 inches, he was compacting 6. But again, you eliminate quite a number of processes, so there's a cost savings there that would probably bring that price down, probably in the neighborhood, I'm just running some numbers off the top of my head, probably in the neighborhood of $12 to $15 a square yard. Finally, like I said, the maintenance supervisors, to me, they're my litmus test. So, when I was working on this, I asked Edward to send me something that kind of shows how he feels about the process and how it worked and what kind of end result he got. And I got this from him. If it works. So, with that, I'll thank you.